Good morning, Year 10. In this video, I'm going to be going over the answers to 5 questions from Week 3, Term 3 for Tuesday. Question 1 says that a bowl of hot soup sits on a table as it cools. At first, it loses heat quickly, but as time passes, it loses heat more slowly. I wrote that twice. As time passes, it loses heat more slowly until it is at room temperature. Which graph best represents this situation? Well, first of all, let's get rid of the fact that we repeated that. We'll ignore that was there. But, so we've got 4 options for this. 3 of them are wrong, obviously. But which ones are the wrong ones? So let's look at this first graph. Okay, the first graph, so we've got temperature and time. Okay, so the higher the line is up and down, the hotter the soup, and the further along it is, the lot more time has passed. So soup started off hot, it looks like, and then it gets cooler, and then starts heating back up again. Now that doesn't actually happen with this. It loses heat quickly, loses heat slowly over time, and then it hits room temperature. So this is actually getting hotter at some point. It gets cooler, but then it gets hotter. So it's definitely not this one. So I'll just do it's not that. Then we'll look at the next one. So the temperature starts, and then it reduces in temperature, but then you'll see it starts to get less steep over time, and it keeps going until it kind of gets to a point. That looks pretty good. It loses heat quickly, and then slows down, and then time passes, and eventually gets to room temperature, which means it's not freezing cold, it's not 0, but yeah, it's still there. So that's looking pretty good. I'm going to do an imaginary tick for that one. We'll just double check the others. So this one, for the third option, temperature starts to go down slowly and then speeds up, and then it goes until it hits 0 degrees. Now, that's not going to be right because it can't hit 0 degrees. It's getting to hit room temperature. And it's not like your room is a fridge. And even if it was a fridge, it's still not even 0 degrees. We're talking about a freezer for 0 degrees. Now, the next option is probably the nicest looking one. The soup is at a temperature, it stays at that temperature, and then it dips a little bit, and then it stays at another temperature. Now, the reason why it's probably not this one is because it doesn't lose heat quickly. It kind of loses it slowly over that first little bit. So it's not going to be that one either. So our imaginary tick before was right. That is the option we want. Now, question 2. We need to expand 3c multiplied by 9c squared plus 2c plus 7. So we're going to use the rainbows for this. So I'm going to have one option there. So the first thing I'm going to multiply, I'm going to do 3 times 9, which is 27. And then c squared times c, I'm going to have 3c, so it's c cubed. Then the next one, 3 times 2 is 6. And c times c is c squared, so we've got 2 lots of c. Well, it's not really 2 lots of c, it's c times c, which is c squared, of course. And then the third one, 3c times 7, that's going to be 21, and just a c at the end. So that's how we expand that one. Now next, to factorize a perfect square. Now some of you may not remember this. I encourage you, if you ever forget something, maybe Google it just to see if it will jog your memory, if you don't have your book with you, or look back through your book. Now, to factorize x squared minus 9, I can rewrite that as, it's actually more of a difference of 2 squares, right? So like this thing is squared and this thing is squared. So I'm going to rewrite it like this. X squared minus 3 squared. Okay, because 9 is the same as 3 squared, which I can rewrite as this. x3, x3. And then one of them I do a plus and one I do a minus. And that's how we do the difference of 2 squares. Okay, by the way, when it's talking about perfect square, that's more specifically talking about just an individual component. Like 9 is a square. Remember, if you want to check that you're right, we can do the same thing that we did for question 2. We can expand it. So I'm going to do that just to be sure. So I'm going to do x times x, which is x squared. X times minus 3 is minus 3x. 3 times x is plus 3x. And 3 times minus 3 is minus 9. So that's going to be the same as x squared. Minus 3x plus 3x is 0. And then we're just left with minus 9. So that's a way you can check. Now question 4 asks us to find the value of x. So to find the value of x, we're going to need SOHCAHTOA. Okay. Now it only works because it's a right angled triangle. We're going to talk more about that in a future topic. But SOHCAHTOA. Okay. Now I need to label this triangle in respect to this angle. So here's my angle, and it's looking at the opposite side. So I'm going to label that as O. The side opposite the hypotenuse, the right angle is the hypotenuse, or it's just also known as the longest side of a right angled triangle. And then the leftover side is the adjacent side. Now the ones that we care about are O and H because they have something. So there's something here and something here. There's nothing with the A. So that means we're looking at SO, as in sine, opposite, and hypotenuse. They're the 3 things we're going to use. So sine of the angle is equal to opposite over hypotenuse. So now I'm going to put in the information. So sine 30 degrees is equal to 10 over x. Okay, now I want to get x by itself. Now there's a neat trick we can do where we actually swap x and sine 30, because whatever's on the bottom I can swap with whatever it's equal to. There's a long way to show why that works, but for this quick video I'm just going to say, hey, that works, let's do it. So we're going to have x is equal to 10 over sine 30, and then I type that into my calculator. So 10 on sine 30 is equal to 20. So that means x is 20 meters. I'm just going to write the word units because we're not sure if it's centimeters or meters or whatnot. Final question, question 5. Find the exact area of this rectangle. So we have a rectangle here and we've got 2 side lengths, but they're surds. That doesn't really change how we solve it though. So the area is equal to base times height. All right. Now the base, in this case, is root 15 times root 5. Now the only barrier here is if you don't remember how to multiply surds. But remember, we just multiply them as if they are normal numbers. So normal numbers multiply with normal numbers and surds multiply with surds. So 15 times 5 is 75. So the area is the square root of 75. Now it said the exact area of this rectangle, so that's technically done. We could say that's meters squared because we're talking about area and be done. But if we can, we like to factorize our surds and get them simplified. So we can see that 25 is a factor of 75, so I can break it into 2. I can say that's the same as 25 times 3. And the square root of 25 is 5, so it's going to be 5 root 3 meters squared. And the reason why we knew that we needed to leave it like that and not go to decimal places is it says exact. Okay, so that's why we finish it like this. All right, that's the 5 questions for today, and we're going to be moving on to parabola.